Okay, Algebra 2, this video lesson will focus on the alternative approach to drawing best fit lines and using them, and that is to create them with a calculator. And I've handed, or actually the website I should say, has a 4-step guide for doing that. So you should go and make sure that you have that document, though I was starting to say I have handed it out because I have to some people in class already, so you may already have a printed copy. The guide, whether you get it from website or I've already received it from me, talks about 4 sections. It's a 1-page document. First being how do you enter the data into the calculator so that you can graph the points. The second being how do you apply a best fit line to those points in your graph. The third being how do you actually tell the graphing calculator an x value that you want to check and then get back a y value that would be associated with that x value. And then lastly, how do you decide how strong the correlation is so that you can get a sense of whether or not that's useful information that you've just gotten from the graphing calculator. Okay, so what I have here on screen is my computer-based graphing calculator, as well as that document that I was talking about, and it shows the steps for the first part of the task, which is getting the data into the graphing calculator and seeing the points. So you can see that the first step here is to hit stat 1, as I say. So, well, there's my stat button. And I can either literally hit 1, like I've called for here, or I could hit enter. The reason is because right now 1 is the highlighted step. I'll just show you that you don't have to hit 1. You could hit enter. And as I say here, you should see a table. And you should make sure that table is empty. Well, in this case, that table isn't empty. So as I say, you've got to scroll up to highlight L1. Well, in this case, if I went up from where I happen to be, I'd go to L3. So I've got to go over to L1. And then as I say, you've got to hit clear and then the down arrow. So that's what I'm going to do. Simply clear, come down, and notice the whole column's empty. I'm going to do the same thing for L2, clear, down. And now my table is empty. Notice I happen to have in this software a bigger screen version of what you would see on your graphing calculator. So I have the empty table. I need now, as it says here, to enter the new data that I want. Well, what I've done is I've picked some different data than you're going to work with. I've picked this table of data that talks about the relationship between age and height for males between the ages of 2 and 19. I didn't want to give the same data that you have. I wanted you to have a chance to practice it yourself. So when you do this yourself, you're going to want to figure out for your data which is the independent variable and which is the dependent. I feel like age is the independent variable, so it'll go in the L1 column, L1 being the X column in this case. And height I'm going to put in the L2 column. So I've got to get over, whoops, I don't actually want to be highlighting L1, I want to be there under L1. And I'm going to put in 2 and then 3 and then 6. So you simply hit 2, enter, 3, enter, 6, enter, and so on. I'll go up and I'll show you how you would then put data in the L2 column. I'm going to have 28 and then 33. Enter, 33, enter. All right, I'm not going to make you watch me do all of these. I'll show you what it looks like with the table complete. Okay, I now have the table completely filled in. When you do this yourself, I strongly recommend that you go through and make sure you haven't made any typos. The most common reasons that I see students making mistakes with the graphing calculator are either typos, simply put. So scrolling down to the bottom, my last number here, notice, should be 19 and then 72. I want to make sure that I don't, oh, and notice that it'll wrap back around if I go past 19. And it's not going to go up, I don't think, to go back to 19. I haven't tried that before. I haven't tried everything with the graphing calculator, so you'll discover some things yourself as you play with this. But there, I don't seem to have any typos along the way. The second most common reason that I see students getting an error message with their calculator is because the quantity of entries in one of the columns is different than the quantity in another column. These have to match. If you accidentally, let's say you were supposed to put a total of 19 entries in L1, and similarly 19 entries in L2. If you only put 18, or if you put 20 different entries in L2 and they didn't match, you would get an error message. So that's an easy thing to do. There's a famous saying among data entry people called garbage in, garbage out. If you put in that information, as good as the calculator or computer might be, it's not going to give you useful information afterwards. Okay, the next step in the guide is to hit graph. So I hit the graph button, and the next step in the guide says don't see anything. Well, in fact, I do see something, but it's strange. Why am I already seeing a line? It doesn't seem like I should see a line. I should be seeing points, because all I've entered is point values. So as it says here, hit second Y, and this brings me to an important point about your graphing calculator. There is this second button in the top left. Notice that every other one of the buttons has at least two different capabilities. For example, this button here has mode and then quit. This second is kind of like a shift button that brings you to the blue function of every other button. So if I hit second and then Y equals, I need to make sure that plot 1 is on. Well, plot 1 is not on. How do I know? It's easier to see over here, I suppose, because it's not darkened. So I just simply scroll over to, whoops, I guess how do I get to, should be able to do it like that. I guess what I do is simply hit enter. Nope, that is not right. Okay, plot 1 is now. Oh yeah, there it is. Plot 1, if I hit enter now, it's going to be on. Now, I hit graph again, and I should see points. But still I'm seeing a line. Still don't see anything. Well, actually, I've left a step out of the guide. If it says still don't see anything, but I do. What I really ought to have done in the guide is I should have told you to hit Y equals at this point and make sure you don't already have an equation in there. It turns out that I do. If you've gotten this calculator from a friend, from an older sibling, and they've used it before, they probably haven't cleared everything out, so you need to clear that. So now that's gone, simply by hitting clear there. Now if I hit graph, I'm hoping to see my points, but I don't. And as it says here, still don't see anything, hit zoom 9. I'm trying to represent to you all the different ways that you might be confused when you use your calculator. If I hit zoom and then 9, my calculator is now going to try to pick the best window to show my points. And there they are. Those are the points, the data points for the data that I entered. Your data is going to be different, remember. You're going to be entering the data from Benny and the water bottle. So your points aren't going to represent this trajectory necessarily. But it gives you an idea of what you ought to be seeing roughly at this point. If you don't see something like this, if you don't see what you're expecting to see at this stage, I strongly recommend that you don't give up, that you go back. Maybe it means rewinding this video, maybe it means going back to the top of the document, the guide, but one way or another go back through all the steps and see if there's a way that you might have made a mistake, and if you can get to this stage of the game and actually see what you had intended to see. I'm now going to go on to how to get a best fit line for those points. As it says, now what I want to do is hit stat right arrow. I hit stat. The right arrow, as it calls for here, takes me over to calc, then 4, then enter. So I've got to get it over to calc. Right arrow to calc. Then I want to hit 4 because 4 is going to be for linreg, the abbreviation for linear regression. Hit 4, or I could have scrolled down to 4. And then the last thing I'm supposed to do is hit enter. I hit enter and I see the equation in generic form, y equals, they say a instead of m, x plus b. And my a value, in other words, my slope is 2.6, b, my y-intercept is 24.4. That actually is the equation for the best fit line of the data that I've entered. People with newer calculators or people with theirs set in a different format may see more than this information. They may see less. They may need to scroll over to the right to see everything. Play with yours a little bit. Nobody has exactly the same calculator as me, maybe not even as the next student to them in the classroom. So you got to play around with a little bit. But generally speaking, your screen ought to look something like this. Okay, in order to move forward from here, you have to clear this off the screen. And often students make a mistake by trying to go straight from here to the next step. What I recommend is you hit the Y equals button. It not only takes you to clear this screen, but it also gives you one more chance to make sure you don't have an old equation in there. So I'm going to do that. I hit y equals, there's no equation there. And as it says here, next I hit vars 5 right arrow over twice to EQ. So let's see, vars, there's my vars button. 5 is for statistics. I can scroll down, as I said, to 5 and hit enter if I prefer. I've got to go over twice to EQ, so I go over 2, and then I hit enter, and it pastes that equation that I just talked about in for y equals. Some people with newer calculators, it doesn't show the equation this way. Instead, there's a right arrow button, and you have to scroll to the right to see the whole equation. But one way or another, it should be y1 equals and your equation. Now if I hit graph, it draws a best fit line to my points. This line is much more accurate than anything I could draw by hand. And the other benefit of the graphing calculator, going back to y equals, is it's given me a much more accurate equation than I could derive by hand. The slope is literally 2.615 and so on, but I would probably have at best rounded it off to 2.6 or 2.5 and probably more like either 2 or 3. And the y-intercept is more specific than 24.4, but my best guess probably would have been 24 or 25. It might have even been 20 or 25. So the calculator is much more accurate than I can do by hand. Another nice thing is the calculator can give me a much more accurate prediction based on that best fit line than I can derive by hand. If I now hit second, trace, enter. So let's see, second, there's my trace button right there, trace, then enter. Notice that it's blinking x equals. So now if I put in a value for x, so let's say that I put in the age 11. That wasn't tried in my data, so I try 11. I hit enter, and I get a y value, 53.19 and so on inches. So what you're seeing on the screen here is a repeat of the equation, 2.6 and many more decimals x plus 24.4 and more decimals to the right. That's my equation. This is the x value I entered, 11, and it's coming back to me with the height that's associated with age 11, 53.19. Much more accurate than I could do by hand. Now, when you do this, as the guide over here suggests, you might get an error message when you enter a value for x. That's most commonly because you've entered an x value that's outside the window. If I try to put in an x of -4 or an x of 59 years old over here, it's outside the window and the calculator won't know how to give you an answer. So what you need to do is hit this window button. Look at your x min, and in other words, the lowest x value that you're allowing in your window, and x max. So an x value, an age of -9, well, I would have to change this x min to -10. -10, now -9 would fit. And if I wanted an age of 99, I'd have to scroll down and make that, let's say, 100. Now if I hit graph again, I'll get a wider range here, a wider domain, I should say here. And notice now my line looks quite different. But it only looks different because I've stretched the domain that way and this way to allow more room. It's still the same line. Okay, let's move on to the last step in the guide, which is to determine how strong the correlation is. In my case, how strong the correlation between age and height is. I hit vars 5 right arrow over to EQ again. Vars 5, I right arrow over to EQ. This time I'm going to hit 7 for R. I do that, and now I've got R blinking there. Once this R is blinking, all I have to do is hit enter, and I'm going to get a value for R. Now, as this guide says, if R is between 0.75, in other words 75% and 100%, or between -0.75 and -100%, the correlation is strong, and so on here. You'll never get an R value higher than 1, that represents 100%, or lower than -1, that's -100%. Negatives aren't bad, they're just negative slopes. This happens to be a positive slope relationship between age and height, and it's a very strong correlation here. It's about as strong as you'll ever see. So that's it for using the guide to the graphing calculator to find best fit. Go ahead and do the same with the data for Benny and the